Okay, this is problem 1047. It's not in your textbook. This is from another book, but it's one of my favorites for regression, especially for multiple regression. And the idea is to try to figure out what would predict purchasing department costs. So what we have here are the number of the merchandise purchased is the first one. Okay, that's our first variable right here. Number of purchase orders and also number of suppliers. So they're trying to figure out, if we spend more on merchandise, is that going to increase cost, or is it the number of purchase orders that we have, or could it be the number of suppliers? Okay, that's the idea. So what's good about it? How come I can't get this? What's good about it is that it's a nice example for a multiple regression problem. So I'm going to do it here. I'm going to set up one of them. Actually, what I'll do is I'll do all three. No, I'll do it's like purchasing department costs and maybe merchandise purchase and number of purchase orders. Okay, just to show you how that would be done. So we're going to go into analyze data. We did this in class, but this is just one more example for you. Data analysis, and I want regression. And our Y input, our dependent variable would be the purchasing department costs. Okay? And our X range, what we want to do is take in two variables here, and they have to be contiguous in order to use Excel for this, okay? So in other words, they've got to be next to each other. So I'm going to take merchandise purchased and the number of purchase orders. And I've got labels here. We're going to put it on a new workbook. Yeah, I guess. Or a new worksheet. And then I want to do some line fit plots, okay? And 2 seconds later, here we are. Okay, let's take a look and see what the line fit looks like. Wow, what a mess, huh? So these are purchasing department costs. Wow, it makes you really wonder what it's really like, doesn't it? Should probably do some scatter plots first. The number of purchase orders looks reasonable anyway. Okay, I'm sure the statistics might explain other things, but this is crazy. I mean, it looks like shotgun output, So this wouldn't help at all. But let's look at our results. We've got an R square of 0.44. Okay, nothing too impressive there, that's for sure. So 0.44, we only have 10 observations though, okay, so that would be a limiter. And if we look at our p-value, it's 0.71 for merchandise purchase, 0.07, which is terrible, okay, so it looks like merchandise purchase has nothing to do with it, and 0.07 for the number of purchase orders, okay, but the model altogether is 0.44. So this is why we would want to compare this to the original regressions that we did individually for each variable. You would do that first. Okay? So it's kind of weird. And I'm looking, here's some stuff from Excel under here too. My computer at work didn't come up like this, but here's our data. You can even put a pivot in here for it. It's a nice... that's by department store. So there's a little bit of tracking error. Not much though, huh? Okay. Oh, this says that the purchasing department costs and the number of purchase orders appear highly correlated, which kind of makes sense. Okay. All right. So what do you think? I think that's probably all you need on this. If there's something that you don't understand or you want me to do something differently, let me know. Okay? All right.